All right, so welcome back for part two of session 9.2. We're continuing on with this idea of hypothesis testing for a claim about the means of two different populations and how they compare to each other. Which one's bigger, which one's smaller, are they equal? All right, so here we go. A manufacturer claims that the mean driving cost per mile of its sedans is less than that of its leading competitor. So there's our claim. Manufacturers claiming that our car is cheaper to drive, the mean driving cost per mile is less, cheaper, than its leading competitor. We're going to conduct a study to test this using 30 randomly selected sedans from the manufacturer and 32 from the competitor. The results are, now I want you to notice something, manufacturer, we're defining that as ones. Competitor, we're defining that as the twos. So we don't get to choose here. But the reason I need to know who's one and who's two is because when I set up the claim about the population means, and when I set up my hypotheses, ones and twos matter. All right, so back to the claim. The claim is that the manufacturer thinks that theirs is cheaper than the competitor. So the claim would be that the mean cost for them, one, is cheaper, less than the mean cost for their competitor, two. Now, as a pair of hypotheses, as a null and an alternate hypothesis, what we're looking at here is, since there is no equality in that statement, the alternate is going to be the claim that mu1 is less than mu2. Remember, I always denote which one's the claim so that when I get to the end, it's easier to do. Right? Null will then be that they're technically greater than or equal to, but we write it as equal to because reasons. Okay. Data. Well, I've done two of these so far, so I think I know what I need. I need an x1, I need an n1, and I need a standard deviation from group 1. So I know that my x1 is 0.48, my standard deviation is 0.05, and my n1 is 30. That was up here, right? I also need data from group 2. I need an x bar, technically a bar, yeah, sub 2. I need a s sub 2, and I need an n sub 2. Looks like theirs is 0.51, standard deviation of 0.07, n sub 2 of 32. That's our n2 up there. We have a alpha level of 0.05. That's right here to run our test. Okay. Now, since we have sample standard deviations from both groups, okay, I need to run a t-test. So that tells me that I'm running a t-test. But if I'm running a t-test, I know what you're thinking. Isn't it a two-sample? Yeah, a two-sample t-test. I need something else. When I calculate my standard deviation, am I pooling to get that or not? So let's look a little deeper. Right here, we're supposed to assume the population variances are equal. And because we're assuming that to be true, that means that we are going to pool, or on the calculator, pool equals yes. All right, so I think I've got everything. If I run into an issue, I can always come back, but I know that I'm running a two-sample t-test because of sample standard deviations. I know that I have stats. My x bar sub 1 is 0.48. My standard deviation for group 1 is 0.05. My sample size is that 30, so it makes it big enough. Okay. My x bar sub 2 is 0.51. Whoops, 1. My sample standard deviation for group 2 is 0.07. My sample size for group 2 is 32. My alternate hypothesis is less than, so I'm going to grab that guy. And then I'm going to select yes for pooled because they're equal. And then I'll calculate. If I need that test statistic, there it is. It's negative, what is that? Negative 1.93. But what I really need is my p-value. My p-value is 0.029. I compare my P to my alpha. 0.029 is smaller than 0.05. When P is less than alpha, we reject the null. But our claim was the alternate. And if we reject the null and the claim is the alternate, we say that there is sufficient evidence to support the claim. So there is enough evidence to support the claim that their car is less expensive to drive. So should we buy one? I don't know. Does it cost more? Because if it costs $5,000 more, but it saves me $7,000 a year, then it's worth it. But if it costs me $5,000 more, but it's only saves me $2,000 a year, well, now I got to drive it for almost 3 years before I'm making money, or saving money, I guess we should say. So I don't know. There's more that goes into it than that. But what I do know is sample standard deviations run a t-test. Since they're 2, it's a 2-sample t-test. And since the variances are equal, we're going to select yes for our pooled. All right, last example, and then we'll move on to section 9.3. Okay? A demographics researcher claims that the mean household income in a recent year is the same in Ada County, Idaho, and Cameron Parish, Louisiana. In Ada County, a sample of 18 residents has a mean household income of $58,300 with a standard deviation of 9,000. In Cameron Parish, a sample of 20 residents has a mean household income of $56,600 and a standard deviation of 15,600. Okay. At a significance level of 0.10, can you reject the researcher's claim? Assume the population variances are not equal. Well, I got a problem here. My problem is those are smaller than 30, and I don't see anywhere in here where I'm supposed to assume, or I am told, that these samples are taken from normally distributed populations. Technically, I can't do this, but I think this is a typo on my part. So I'm going to go ahead and fix that on your copy, and I'll be right back. All right, so on your copy, it's fixed. So let's just pretend that this said that they were normally distributed, right? All right, so this example does not lay out for us which group is group 1 and group 2. In the other examples, it kind of told us, right? And it told us. And it told us. This one is going to be an example where it clearly doesn't say which one's group 2, which one's group 1. We're going to go with that. Now, I'm going to go back to what I started with in the last section. I run into Ada, Idaho first. So that's 1. Cameron Parish, Louisiana is 2. The claim that the researcher made, the claim is that they're the same. So the claim is that the mean cost or the mean household income in population 1 is the same as the mean household income in population 2. That is Idaho and Louisiana respectively. As a pair of hypotheses, a null and an alternate, since our claim contains equality, it will be the null. Our alternate will be that they're not equal. Right? I've done enough of these now where I know what I need. I need data. I need an X bar sub 1. I need a standard deviation from group 1. And I need a sample size from group 1. Ada County sample 18. Mean income 58,300 with a standard deviation of 9,000. Cameron Parish 20, so X bar sub 2, S sub 2, N sub 2, 20. Mean income 56.6. Standard deviation, 15,600. Alpha level 0.10. Variance is not equal. So no pooling. I think I've got what I need. Stat. 2 sample t-test because sample standard deviations. Okay, so a point. Haven't said this before, but what if one data set was a sample standard deviation and the other data set was a population standard deviation? What will we do? You're never going to see that. So don't even worry about it. Honestly, now that I'm saying those words, I don't know what you would do. I'd have to look that one up, right? They're either both going to be samples, t-test, or they're both be populations, z-test, right? So t-test, I've got my data, x bar sub 1, 58,300, standard deviation 9,000, sample size 18. X bar sub 2, 56,600, sample standard deviation 15,600, sample size 20. Sample size 20. Alternates not equal to, so I'll select that. Pooled is no because the population variances are not equal. Give me my answers, please. If I needed the t, the standard test statistic, that's 0.401, but I got a p-value. Now this is weird. We don't see this very often. Look at that p-value. 0.68. We don't see big p-values like that very often, but it can happen, right? Compare p to alpha. P is greater than alpha, which means we fail to reject, right? I failed to reject the null and the claim is the null, so I will say that there is not enough evidence to reject the claim that they have the same mean. So I don't have enough evidence to reject that claim. I'm failing to reject the null. The claim is the null. When we fail to reject the null and the claim is the null, there is not sufficient evidence to reject the claim. All right. That brings us to the end of section 9. What was this? 9.2. I'll see you all back here for 9.3.